All right, Chan Physics. So just wanted to go through this worksheet so you can see right here. We're going to start out with this velocity and acceleration number one worksheet. And a lot of us just need reminding that there is some real benefit to the four column method. And you may think, don't want to do it. Seems like a lot of work. Or maybe you might say to yourself, I already know how to do this. This problem is easy. I can do it without it. And that's happens all the time. But the bottom line is we're starting out with some easy problems in physics, and we're going to get harder and harder and harder and harder. And so, what we're trying to do is get you guys to know this method now so that you can then use it when we get things a little bit more difficult. And so this is our problem set. And remember that between Mr. Block's class and Ms. Moise's class, the four column method is a little bit different. But the bottom line is we all list what we're going to find out, what we're going to do. We're going to choose the equation. Those things are the same. And I think Ms. Moise's step 3 is right here to rearrange the equation. I like to insert the numbers and then solve for the variable because sometimes the numbers make things easier for us, okay? And then always in my class, fourth column, we write down the answer and we ask ourselves, does this make sense? So I'm going to do two problems live for you guys so you can see it happening while I actually write it down. And then I'm going to go through the key after this. Okay, so two parts of this video. So let's say you're just like, I want to know how to do problem 5. That's going to be further down along in this video. Okay, all right, so we're going to do the first question. It says, we read this. It says, what is the average speed of a car that traveled 300 miles in 5.5 hours? When I do this problem, I don't do it that way. I don't read the whole question. I stop whenever there's something that it says that I need to write down in my list. So you can see in my first column here, I'm going to make a list. So it says, what is the average speed of a car? And I stop right there. I go, that's something that I need to find. So they're going to ask me to write down the speed. They're going to ask what the question, that's what they're asking me to find. And then they say that a car traveled 300 miles. That's a distance. So I'm going to write down D equals 300 miles. Now you notice I'm not just putting down 300 miles. I'm writing down D equals 300 miles because that's going to help me out later. And then it says in 5.5 hours. And so what is that? That's a time. So time is 5.5 hours. So now what does the four column method do for me? Well, first of all, it gives me a starting point. Anybody can look through the words and list out the numbers. It's not like a thinking problem. It's not even like hard. It just gets us going, right? So now I've already got something down. So hopefully I can keep going from there. Now what I want to do is I want to cover up those numbers. And I just want to look at those variables right here. So it's S, D, and T. So now when I look at my equations that I have to choose from, first of all, there's only one that has 3 variables in it. Everything else has 4. And so when we think about whenever we get a problem with 3, we'd say, okay, the choice of what equation we're going to use right here is pretty simple. It's right here. That's the only one that we could possibly use. And then when we look at the variables, does it have speed in it? Well, it has velocity, and we're talking about the same thing when we're moving in a straight line. Speed and velocity become the same. It's only when we've got windy motion that velocity becomes different than speed. All right, does it have a distance? Well, yeah, delta x is a distance. And does it have time? Well, yes, it does. And so our choice of equation in the second column is pretty easy. Velocity equals distance divided by time. We write it down. Okay, so in my class, the third step is insert the numbers and solve. So V equals 300 miles divided by 5.5 hours. Okay, I've substituted in. I said, I don't have a number for V, or speed. That's my question mark. So I leave it. I have a number for D. Put it in. I have a number for T. I put it in. So we're good. And here now is the easiest of all problems. There's no algebra to do here because why? The variable is by itself. And so all I need to do is put this in my calculator and get an answer. And so when I do that, I get V equals 54.55 miles per hour. Okay. And the question then becomes, we ask ourselves, does this make sense? So if a car drives 5.5 hours at this velocity, will it go 300 miles? Well, in the first hour, it will go 54. In the second hour, it will be at a 108. In the third hour, we should be somewhere in the 160s. In the fourth hour, we're about 200, 220, right? The fifth hour, we're closing in on 300. So our number is like close. We don't have to be sure, but we need a number that makes sense, and this number makes sense, and so we're happy with it, and so we're ready to celebrate and go on to the next problem. Okay, I'm going to skip problem 2 until we get to the thing. I just want to show you guys how the 4-column method helps us pick out the equation that we need. Okay, so I'm going to do problem 3 live, and then I'm going to go through the key. It says, while traveling along a highway, a driver slows from 24 meters per second. Okay, I'm going to stop right there. That's a number. I definitely need to put that in my list. So I'm going to put that in, and I'm going to say to myself, is that the first velocity or the second? Because I can see right away that there's a second velocity coming. So when I say first, not the first that shows up in the words, but the first in time. Meaning like, at 2 o'clock, I'm at 24 meters per second. At 3 o'clock, I'm at 15. So at 2 o'clock, that's my initial velocity. Right? So the initial velocity is 24. It says it slows down to 15. That's my final velocity. That's 15. And it says in 12 seconds. That's a time. So I'm going to put 12. And then it says, what is the driver's acceleration? So I write down. Right, so you see how it's called parsing. It's basically taking apart a sentence and constantly making sure that you make a list. So I have made a list while I'm reading this. It just says use the table above to show the 4-step method. So now I've got a list of 4 variables. What does this mean? Well, number one, I can't choose the first equation in our grouping because that equation is only got 3, right? So I can't choose this one. And I can't choose either of these two because these two both have distance in them. And I don't have distance, right? They're not asking me to find distance. They're not telling me a distance. So I've already eliminated this one, and this one as choices. And really now I'm left with these two. And if you remember from our conversations, these are actually the same equation, just written differently to help us. And so we're going to choose the one that makes it easiest on us. We have to solve for A. So why not choose the equation that's already solved for A, this one right here? And that's the one that we're going to choose. So A is equal to VF minus VI divided by T. That's our equation. And then I'm going to substitute. So A we don't know, so we'll leave it there. VF is 15. Minus the VI, which is 24, divided by 12. All right, so now some of you guys might put this in your calculator and get, I think, 13. And that's just a problem with the way that you're doing the math. Or your calculator, sorry. So, but 15 minus 24 is negative 9. And then divided by 12. And so the answer is negative 0.75, negative 0.75. And that didn't come in, but I'll just put it right here. So A is equal to negative 0.75 meters per second squared. Okay, are we sure about that? Well, if this is in meters per second and this is in seconds, then our unit for acceleration has to be in meters per second squared. And that's what we've been talking about. Acceleration is in meters per second squared. So if you haven't noticed, I've already started to ask myself, does this make sense? Well, certainly my units make sense. Does a negative acceleration make sense? Well, they slow down, so that makes sense. And then does 0.75 make sense? Well, almost a meter per second for 12. We've only slowed down 9 in 12 seconds, so it should be a little bit less than 1 meter per second. So I'm looking in the ballpark. I'm pretty happy. I've got that right answer. Okay. All right. So now I'm going to grab the key And I'm going to show you guys the remaining ones a little bit more quicker. And so let's say you've got a problem with a certain one, you can hopefully find it, okay? So here's the key. And we did the first problem, so I'm going to look at the second problem. In the second problem, if you're looking at the key, I've done the list. I've got a distance of 1,500. 330 is my velocity, and they asked me for a time. I write down the equation, and I get this 330 equals 1,500 divided by t. Right? Most of us have trouble with this problem. Remember the goals of algebra. Get the variable by itself, and whatever you do to one side, do the other side. And so the idea here is t. I got to get t by itself. And t is in the denominator. And we hate that. We hate when the t is in the denominator. So if you see how I just wrote this arrow down and said, okay, I rewrote it and I said, okay, first thing I want to do is multiply by t. Because when I do that, these two t's will cross out. Whatever I do to one side, I have to do to the other. I've got a t. Now, only thing I've done now is I've made t on the top. Okay, t times 330 equals 1,500. Now it's an easier question because now I just got to get t by itself. I got to get rid of the 330. So I divide by 330. Whatever I do to the one side, I do to the other side. Divide by 330. And I get t equals 4.54 seconds. All right. We will trick you. We'll try to make sure that you do this correctly because this is something that for some reason math classes are not teaching in our district. And that is, how do you solve when the variable's on the bottom? And the trick is always multiply by the variable to get it up on the top and then work from there. All right, so that's question 2. Let's move on to question 4. Those of you guys in Moises class, at some point you will see that my questions, there's a different order to them, but we basically have the same questions. You guys might have one extra question. I don't know how that happened. All right, question 4, race car driver. We've got an initial velocity of 85. We've got an acceleration of negative 8.9 and a time of 4.5, and they ask for x. So they don't tell us the final velocity. So when they gave us x, right, or they asked us to find x, then now we're like, okay, we've got the beginnings of trying to pick out which one of these is going to work. And so when they have x, we have to say to ourselves, well, I must be choosing from these two. And if I'm choosing from these two and I don't have final velocity, well, I'm only left with this one right here. And so the choice of the equation is not that hard. And so I shouldn't say that. It is hard. This is hard work, you guys. I know this. So I write down the equation and then I put that into solve. All right. Now, some of you guys might have trouble with this, just putting it in our calculator because this is a positive number, 85 times 4.5. This is a positive number. Plus 1/2 negative 8.9 times 4.5 squared. This term right here is a negative number. And so if you took a little time, you could just write down this number minus this number and hopefully get 292.49. Okay, but sometimes if you make a mistake, you certainly don't want any of this squared. The only thing squared is the 4.5. Okay, so we're back in. Sorry, I had to take a break there. So this one is really back to simple in that when we do actually read through all of this, and some of the wording is kind of weird, I agree with you. After 3 seconds, they're running 6.67. After 10 seconds, they're still running 6.67. So we have to assume that this person is running at a constant velocity of 6.67. The time is 13, and they want to know the distance. Right away, when we look at that list, we say to ourselves, 3 variables. There's only one equation that has 3 variables. I have to choose this one. And then once we put those numbers in, remember, when you substitute in, you substitute the numbers for what they are. So don't just like put something here and then put the 2 numbers on the right side. Do we have a number for velocity? Yes, we put 6.67. Do we have a number for delta x? No, we leave it as d. Do we have a number for time? Yes, 13. So we have 6.67 equals d divided by 13. How do we solve for d? We have to get rid of the 13. How do we get rid of a 13 in the denominator? We multiply by 13.